Good afternoon. Assalamu alaikum, everyone. I'm here to give a small brief introduction of the webinar before we let in our speaker, Muhammad Masiuddin, for the webinar. I would like to welcome all of you to this beautiful webinar we are conducting today. And this webinar is basically a continuation of the series of the webinars we have committed ourselves to do it at least on a monthly basis. There are a lot of webinars upcoming now in future, and you have to stay tuned for all our updates for the future webinars. So I would like to take an introduction of how our the group is functioning. Our group is basically a WhatsApp-based group, and the idea of this group is to connect the engineers, the engineering community from all the backgrounds, client representatives, consultants, contractors, manufacturers, suppliers, subcontractors, specialist subcontractors, whoever are related to the MEP field are welcome to this WhatsApp group. The functionality of the group is based on the WhatsApp. And the idea of having the WhatsApp is to give quick solutions, to share the expertise from various teams. The, the engineers should have quick response to their daily solutions to their daily problems. Again, the idea of this group is we all know that now we are in entering into an we have already entered into an era of digitalized world where things are moving very quick and faster. So our needs are also becoming quicker and faster. So to share this idea, to have all the engineers communicated, to share their experiences, and so that we can solve the problems of the engineering community, we are connecting it through the WhatsApp. And as you all know, we do have our YouTube channel, we do have our LinkedIn page, we do have our WhatsApp channel, we do have also our Instagram page. So I'm requesting all of you members to be active in all these other social media link pages as well. Now, coming to the uh, webinar part, I will take you to a small, brief introduction of our uh, guest speaker, Muhammad Masiuddin, who has got a huge, tremendous experience of not say few years, we can say 30 years of experience Muhammad Masiuddin has got. And he has trained many engineers. He has given a lot of uh, uh, support to a lot of engineers and engineering community. He has nurtured many engineers into the field. And the good part of Muhammad Masiuddin is he has into various fields. He has also done not only sales, but he has given support to the consultants during the project development stage, during the specification development stage, during the designing stage. He has given tremendous supports to the designers as well. So we can imagine the amount of experience he has on hands, which he can share with us today, inshallah. And apart from this technical expertise, he is also good in development of the market. He has worked in Middle East, South Africa, and Asia. He is right now in strategic business development. He is serving the SKM Air Conditioning LLC in the pumps division. So his expertise with us, we would like to thank Muhammad Masiuddin to accept our invitation and give us his beautiful thoughts over the chill water pump applications, sizing, system design reports, so that we all benefit out of his expertise. Muhammad Masiuddin Saab, Assalamu alaikum. and I'm now giving you over the table so that you can take over for your beautiful expertise to all of our attendees and let it be shared. Thank you very much. Go ahead.
Thank you. Thank you very much, Mr. Sayyed. I really welcome and hope I'm audible.
Yes, sir, you are audible.
All right. So first of all, thanks a lot for this community itself of UAE MEP engineers community and Mr. Sayyed for giving a good introduction about me. Maybe I don't deserve such kind of introduction. And I also welcome to the whole team and I appreciate your time and your presence during this webinar where we will specifically discuss about the pumps used in the chill water systems and what are the roles basically for all different kind of pumps which are used in the chill water segment. What is the chill water circuits all about and how do we use the chill water system when it comes to district cooling and how we are going to optimize the solutions using and utilizing various aspects of technological advancements which we have done during the recent years. And hopefully, we will also get to know about different kind of orientation of the pumps itself and the type of applications which are used basically in the chill water segment. Allow me to share my screen to make the slides.
Yes, sir. You can kindly share the screen.
Guys, is it visible?
Yes, sir, it is visible.
Yeah. So as I said, we will discuss about the various types of chill water pumps which are used in the chill water segment and the chill water system itself, its applications. And we also look forward to some sample calculations of how we basically select a pump which is optimum in terms of its capacity, power rating, and everything. Let me go ahead. Right. So objectives of this seminar webinar basically is to see the role of pumps which are used in the chill water systems and the various type of pumps which are used in the chill water segment in the chill water systems, and we can explore the applications of these pumps and the system arrangements like the type of circuits which are there, which are available and which are prominent in any chill water segment and in the chill water system. And we also look forward to review the key pump selection parameters, which are designed by the basic factors which are like flow rate and head. And also we walk through some sample pump calculations as well. So guys, if you look at the typical chill water circuit, which is used mostly in our chill water segment, if you look at the drawing itself, it shows that the water is pumped, chill water pump pumps the warm water, which it has received from the building as a warm water, and it
Sorry,
pumps it to the
am I
chiller.
please hiding the people's attendance and all? Can we maximize the screen so that it should fit to the screen? The presentation.
Okay, let me adjust.
That will help more clear visibility.
Okay. Is it clear now? The visibility is good?
No, sir, your screen is not visible.
No, we need to hide all the attendees. Can somebody assist? If somebody knows some command, please help. Attendance only attendance.
Yeah, how is it now?
Now it is okay, sir.
Yeah, fair enough.
Yeah.
We can.
Okay, guys. So this is a basic chill water circuit, a small circuit for chill water, where the pump, basically the chill water pump itself, takes the water, which warm water coming back from the building on the return side, and pumps it to the chiller. And then through the chiller, it goes to the building loads, which is the cooling loads like AHUs, FCUs, etc., and rolls back to the pump. So it's basically a closed circuit. So all the chill water pumps and the chill water segment comes under the closed circuit. Sorry? So what it does basically is it circulates the chill water from chiller to different equipments like air handling units and the fan coil units, and it goes to the last fan coil unit and comes back on the return side back to the chill water pump, which again pumps this chill water through the chiller to again to the building. So basically it's a closed loop, which is called the closed circuit. So all the chill water pumps and the chill water segment itself comes under the closed loop. So what it does basically is chill water pump itself, it is considered as the heart of any air conditioning system or the cooling system or the HVAC systems in the building. So similar to what heart does to the body by pumping the blood, the pure blood across the body, pumps the water, the cold water, the chill water across the building.
Excuse
in
me.
different fluids.
Hello.
Yes.
Yeah, sir. How are you?
Yeah, I'm good. I'm good.
Yeah. The question is in the circuit we have seen the condenser arrow is down. This condenser arrow is down to the evaporator or something.
Yeah.
Yeah. So this is
No,
like
no.
we are talking about the
In
water.
in the drawing, we haven't, clearly indicated how it goes inside, the chiller itself. So we have just drawn it through the evaporator.
Okay.
Yeah.
And also like there is a, you have said something like heart of something that we missed. Can you again tell like what?
Basically, yeah, the chill water pump itself is considered as the heart of any air conditioning or chill water system in the building. As
Okay.
similar to the heart which is in our body, which pumps the blood across our body, through different parts of the body. The chill water pump also pumps the liquid, which is water in this case, to different parts of the building and then comes back. The same water, when it gets warm, it comes back on the return side of the pump to the suction side. Again, it pumps through the chiller to get it cooled. So this
Okay.
circuit basically is a closed loop circuit.
So one question is closed loop. You mean to say the water will not lose anywhere?
No, there will be a loss of water, of course, within the
Then
system because of evaporation, because of the leakages and all. So there will be a system called pressurization unit, which consists of
okay.
pumps, again, to pump the water, which has got a brake tank, which always has got water inside. And then there's a pressure vessel to maintain both the pressure and the water across the systems, chill water system.
Okay. Thank you.
Yeah. So all the losses and everything are made up by the pressurization unit. Yeah. This is a typical layout of how the chill water system, which includes the chill water pumps in the building works. If you look in the drawing, there are basically two chill water pumps, chill water pump 1 and chill water pump N, which throws the water to two chillers, which are chiller 1 and chiller N. If you see the green lines, these are indicated for the supply side, which are supplying the chill water from the chillers to different AHUs here, but it could be FCUs as well, fan coil units as well. So chiller 1 is pumping the chill water to air handling units 1 and 3. And the second pump, chill water pump N, is pumping the chill water to air handling unit 2 and air handling unit N. And similarly, the water, which is warm water coming out from the buildings, is returned back on the return line, CHWR, to both the chillers respectively. And if you see here in the circuit itself, there are like air separator, expansion tank, and water treatment. Water treatment is basically a dosing unit. And the expansion tank, as we discussed in our last slide, which is used in the pressurization unit as well. This expansion tank provides both pressure and water, which is lost either due to evaporation or leakages within the piping system of the chill water. And then this water basically is being treated, because since it's a closed loop and a closed circuit, the water gets contaminated within the pipes and within the system. So it is being treated by a dosing system, which is an automatic dosing unit, which has got chemicals inside, and then which it has a sensor which senses the conductivity of the water. So the moment conductivity, we preset certain conductivity, which is prescribed by specified by DEWA. Certain number of microsiemens per centimeter of conductivity is needed for the water, to be within the loop. So when the dosing unit is having a sensor on which we will specify what kind of conductivity we are looking at for the water. The moment the conductivity of the water goes above that point, immediately this dosing unit starts automatically, and it pumps liquid, the chemicals inside the pipes, so that the water gets purified again, and it goes back to the chiller and through the pump. So this circuit continues. So that is the reason why the dosing units are used, since it's a closed loop and there will be a lot of contamination inside the chill water piping itself for the water.
Sir, I have a doubt.
Hmm.
Sir, for
Please.
the for water treatment, is there any lifespan?
Lifespan as in for the water itself.
Yeah, water treatment. You are saying like you are saying like you are having one
Sensor,
filter, right? Filter
sensor.
sensor. So it is having any lifespan?
No, sensor has got, see, the dosing unit itself has got its own warranty,
I have one doubt regarding this pressurized water treatment unit.
Yeah.
What will be the pressure rating and flow for the pump for the water treatment?
Gentlemen, sorry to interrupt you. If we can keep all the questions at the end of the webinar, we will have a Q&A session and all of your questions will be responded. Thank you, please.
Okay, noted.
So shall I continue?
Yes, Minasa, please continue.
Okay, now coming to the classification of different chill water pumps, which are used basically in the chill water segment. So we have on the left hand side, if you see, it's a end section pump. End section pump. Which is called a long coupled pump, because it is mounted on a common base frame with pump on one side and the motor on the other side, which is coupled with flexible coupling in between the pump and the motor to connect the shafts from both the sides, the motor side and the pump side, with the coupling. And after the fabrication of this unit is done, it is dynamically balanced and the alignment is being checked whether the pump and the motor are on the same unit of length and measurement and etc. And when the alignments are okay, then the pump gets started. This is the end section pump, which is used mostly in the primary circuit of the chill water system. So for you all, the primary circuit is the one for which supplies the water from the tank up to the chiller, and it runs on constant speed, which is in our case it's mostly it is 4-pole, so 1450 rpm. The pump runs on the constant speed because there is no variation in the pressure. It is just transferring the water from point A to point B. So in this case, point A is the tank where the water is being held, and then the point B is the chiller. So that's the reason why it's made in the primary circuit, and it has got the pressure rating of up to 16 bar, which means if the system pressure in the building is, let's say, 6 to 7 bar or 8 bar, this pump can easily handle those kind of pressures. So which is used mostly in the primary circuit of the building. And then you see the other pump, the second pump, which is vertical inline. Okay, and then, sorry, for the end section pump, the section is from the horizontal section. It has got an horizontal section and vertical discharge, top discharge. And these type of pumps are like, which are called, like easy to remove. And which are also called BPO type of pumps, which is back pull out type, because without disturbing the piping connections, we can easily maintain these type of pumps. We can take out the pump itself and open the pump and replace the bearings, replace the mechanical seal, shafts, etc. We can do it without removing the actual piping connections. So that is the reason why it is called as back pull out pump type of pump. And this is mostly used in the primary circuit of the chill water segment. Second pump is vertical inline pump. which is used also in the primary circuit, but these pumps are used mostly where there is a restriction of space in the project site. Because if you look at the orientation of the pump, it's vertical in nature, and you can easily connect the suction and discharge within one line. And for these type of pumps, you don't require alignment because it is already closed coupled pump. There is no alignment required, and there is no requirement of any inertia base foundation at the project site, and it saves the space horizontally. So wherever there is a restriction of space, these pumps are used mostly in the primary circuit, but we can also use it in the secondary circuit as long as the building size, the tower size is not very high. Maybe say up to 45 or 55 kilowatt of motors of pumps we can use if it is falling under either primary segment or the secondary circuit segment. Then the third pump, which is used mostly in the secondary chill water circuit. This is a horizontal split case pump. Unfortunately, I don't have the blown up picture of this type of pump now, as of now, because this pump is called horizontal split case because the name itself indicates when you split it into half from between, it has got two impellers, two mechanical seals on both the sides, and you can take the suction from both the sides of the pump. The other side is not visible in the drawing. You can take the suction from both sides of the pumps. And these type of pumps are mostly used in the secondary circuit because the pressure rating, the nominal pressure of these pumps, the casing pressure of these type of pumps starts from 16 bar and goes up to 30 bar. It means if, let's say, a typical building has got 80 floors and we need to pump it through the roof and to the last FCU, and the head is about 150 meter, this can easily handle because it can handle up to 30 bar of nominal pressure. So the system pressure mostly in the chill water segment will not exceed about say 12 bar or 13 bar, maximum 15 bar, based on the type of size of the building itself. So these are the three different kinds of pumps with different orientations. The first one is horizontal. The second one, it's vertical. Third one is horizontal as well, but which has got, which gives larger flows and large heads, and it can sustain a lot of pressure as well, up to 30 bar. So these are three kinds of pumps which are normally used in the chill water applications. Okay, so as we were speaking about the speeds, for the primary circuit, normally the pump runs on the constant speed because there is no variation of pressure, there is no pressure load. The basic principle of working for the primary pumps is to transfer the water from point A, as I said, to point B, which is from the bottom tank, which is located on the basement, up to the chiller. So the pump runs on the constant speed, which is 1450 RPM here for 4-pole motors. And when we say variable speed pumps, these are basically used in the secondary circuit because the load depends on the pressure. The load of the water itself, the chill water, really depends on the pressure there. In the primary circuit, there is no point of pressure at all because it is just a transfer of water. Whereas in the secondary, since it is going up to the last point in the building, the last FCU, and we select the pump as per, when we are calculating the head also, we go up to the last FCU, the longest route, and then the water comes back to the pump again. So that case, since these are varied loads, variable speed pumps are used mostly in the secondary chill water circuit. And now with the variable speed pumps, you can regulate the speeds from, let's say, 20% of which is 20 hertz or even 10 hertz up to 50 hertz. So since the VFD runs on frequency, which is up to 50 hertz in our thing, this part of the world, it's with 50 hertz frequency. So 50 hertz is considered basically as full load, which is 100%. So now if there is no demand, there is no load required by the chiller, and the chiller needs less water, then we can run the pump from, say, starting from 20%, varying it up to 100%. So 20, 60, 50, 40, 80, whatever the demand is as per the chiller, we can vary it. And in this kind of pumps, we can save a lot of power as well, because when there is no requirement of less requirement of load, obviously we can run it on less speed or less frequency, which will consume less power as well. So the power consumption can also be very good here. Whereas in the primary circuit pumps, which is constant speed pumps, even if the load required is less or more, it runs on the constant speed, and it takes the complete power, and the power consumption in that case will be higher than when it is run when the pump is running on the variable speed. Now, so when we spoke about the end section pumps, which are used mostly in the primary circuit of the chill water segment, this is the kind of pump which we're talking about, which is also called BPO, because it's like back pull-out type, where without disturbing the piping connections, you can easily do the maintenance of the pump by replacing the seals, bearings, shafts, etc. And this type of pumps will give cater to a capacity of up to 400 liters per second and head up to 150 meter. And of course, the efficiencies typically depends on the type of pump being selected, and it really depends on the duty conditions as well. The best optimum duty conditions will get the best optimum efficiencies within the pump itself. So, but typically it ranges between 70 to 85% of the efficiencies. And these pumps run both on 50 and 60 hertz. 60 hertz for countries like Saudi, USA and all, and 50 hertz for us. And the orientation, as we discussed even in our last slide, it's like a horizontal end suction pump, which has got horizontal suction and vertical top discharge. And these are frame mounted. These are mounted on the frame, base frame, with coupling. Now the coupling can be of various types. You know, it could be like flexible coupling, it could be spacer coupling, it could be a spring coupling. You know, like there are basic different kinds of couplings which are in use. And also with the type of coupling is based on the efficiencies, different efficiencies and different duty conditions. We can use a different kind of couplings as well. And of course, the drive options will be like direct electric motor drive. It can be integrated with all these type of motors like IE3, IE4, and even IE4 5 motors are in use by us in this part of the world, where the efficiencies are much higher than the previous IE3 and IE4 versions. And IE5 motors are also compatible to a lot of integrated logical, taking the parameters, basically the logical parameters which are run by using IoT enabled things we can do with IE5 motors compared to IE3 and IE4. What are the advantages of this in the chill water systems for the end section pumps? Because it is simpler in design. So obviously it lowers the cost of the pump itself, and it is easily accessible for seal and bearing replacement, as I told you, since it is BPO type, back pull-out type. The maintenance part of the pump is very easy, and it's available in multiple material of construction. MOCs are like cast iron, bronze, stainless steel, etc. Now, but the typical specification for our chill water pumps here in this segment is like we use mostly with cast iron casing, bronze impeller, and stainless steel shaft. Most of the pumps are being specified with these specifications. But obviously, I mean, when there is a requirement for, let's say, for example, the water quality itself, when it is very aggressive or something. We can also prefer stainless steel 304, 316, 316L, or even duplex pumps. So we do have various options of material for these pumps as well, and which are used suitable for small to medium chill water systems. Why small to medium? Because these are like capable of handling a certain type of pressure, like 16 bar, up to 16 bar only. So it can cater to small range up to medium range. You cannot go with a higher range of capacities, because the system, the nominal pressure and the casing pressure of these pumps are maximum, it is limited up to 16 bar only. And the compact design, of course, saves space in the pump room as well. And the second type of pump which we have seen in our last slides is vertical inline pump. Basically, as I told in the last slides, that these pumps are used when there is a restriction of space in the project site, and it also saves economical pricing, because you don't need inertia base, foundation, the concrete base and everything, because it's already close coupled pump, and there is a mounting in the bottom of the pump itself, where you can just secure it to the ground, and with bolts and nuts you can easily install these pumps. And then even the maintenance is also very easy for these type of pumps, because you don't need to disturb the piping, because it is an inline pump. If you see in the picture also, the suction and discharge are in one line, and you can easily connect it to the chill water pipe. And it can be run now in the present lot. This pump which you are seeing in the picture is without VFD. Now there are pumps which have come with built-in VFD, which the VFD is mounted on the top of the motor itself, so that you don't need different control panel where you have all these VFDs in the panel, and then you are giving the connection, the power supply from there to the pump itself, and the pumps are running. And without that, now the pumps which are coming with built-in VFD are more prominent now, and which are being used in most of the projects. We have supplied, I want to share one case study where we have supplied pump with built-in VFD and display screen very recently, where we have found the pump to be very useful. It so happened that there was an installation done by our team for one chill water pump in a very big building here in Dubai. And then the pump is meant for pumping about 70-75 liters per second of water to the chiller. And when the connections are done, the installation is done, and when the commissioning started, when we started the pump, it was showing that it's getting only 44 liters per second instead of 70-75 liters per second. So we checked back with all the valves related, in the piping and everything, but we couldn't go through. We couldn't find anything wrong. But fortunately, since the pump was loaded with the pump itself was loaded with complete integrated system, wherein we had the display where the pump itself will show how much water it is pumping. So it was showing like 70-75 liters per second. But when they were checking it at the chiller, it is not giving, it is giving them only 44 liters per second, and the chiller was getting tripped, and it was not even getting started. So when we found that, fortunately for us, since we supplied this with all the integrated, IoT enabled things, we could easily see that the pump was already pumping about 75 liters per second of the water. Then we started checking all the valves and everything. We found that the valves were open to look from the outside. But when we opened the valve, one of the valves, the disc was not operating. The disc was completely closed. So it was really, really unfortunate. But when we opened that disc, even the chiller was receiving about 70 liters per second of water now. So with these kind of pumps, this is one of the biggest advantages today when it comes to utilizing the optimization of the pump itself. Even in the chill water pumps, these kind of things were not available. Like when we started using those pumps, we were all using it only on the manual side. They were not even used with the VFDs. So luckily and fortunately for us now, we have a lot of development in the technology, and we have got a lot of IoT enabled things, which will give us a clear indication, and which saves a lot of time, energy, and which are more economical, you can say, in the long run. All right, guys. So let's go to the third pump, which is if you can see in this picture, it's a split case pump. So basically, if we split this into two halves from center line, so both sides have got, each side has got one impeller and one mechanical seal. So it is basically called a double suction horizontal split case pump. So double suction itself, the name indicates that you can take the suction from both the sides. And these type of pumps has got larger flow rates with larger, huge, higher heads. It can take care up to 20,000 meter cube per hour of flow rate, and heads up to 250 meters. And these pumps are typically also used in the district cooling plants, where we need about, say, 250 or 300 kilowatt of motors. These pumps are capable of handling those kind of heads and flows, and also to handle that kind of system pressure, because the system pressure in the district cooling plant will be much higher than any of the buildings. So this is capable of handling those kind of pressures, flow rates, and even the dynamic heads. These kind of pumps also have got higher efficiency compared to the end section pumps, because in end section we can typically have about 70-75% of efficiency based on the type of pumps selected. But here in this case of split case pumps, we can have higher efficiencies of reaching up to maybe 90% sometimes, depending on the duty conditions of the pumps. It runs on 1450 RPM, which is with 4-pole motor, and which is preferred for chill water to reduce net positive suction head and noise. And it is driven by motor as it is, and with controlled by VFD as well. So horizontally split casing allows easy top access. So even these type of pumps are not very tough, very difficult to keep the maintenance on toe, and it can be maintained very easily. Applications like, obviously, I mean, wherever there is a chill water involved, there is a chill water pump. So like offices, malls, hotels, even in industries like factories, data centers, and with district cooling, as I told you, and of course with the retrofit and replacement jobs as well. So these are some of the typical applications of the chill water pumps. Okay, now when it comes to system configurations, what do we mean by system configuration is basically in any chill water segment in a chill water system, there ought to be different circuits, because if it's a high-rise building like a big tower, we cannot have with single circuit of chill water pumps. So basically we start with primary pumps, as I told you in of my earlier slides as well. The purpose of this type of pumps, the primary pumps, is to pump the water from the source to the chillers, and which runs on constant speed, because it is not varying with varying loads. It is just to transfer the water. Then there is a second circuit, which is primary secondary circuit, which is called secondary chill water circuit, and which has got the pumps near the chillers to supply the chill water which is already been chilled, been made, the delta T is achieved, and about 7 to 8 degrees centigrade off coil, the temperature of water which is being sent to the building loads in various equipments like air handling units and fan coil units, and it reaches up to the last fan coil unit, which is the longest route in the building, and then again comes back to the water source. From there, the primary chill water will again pump it back to the chiller. So that's why it's a closed circuit. Then there is another circuit as well for high-rise buildings. You know that when there is high-rise building and there are huge malls and everything, these kind of buildings and malls requires another circuit of pumps, which is called tertiary pumps, which are fixed, which are installed to take care and to boost the water from the point where the secondary chill water pump ends, from there to the last point in the building. So tertiary pumps are also into play with mostly 90% it will be with the high-rise towers. So buildings, let's say about 80, 85-story buildings, 70-story buildings do require these kind of circuits. Okay, so let's look at a typical pump selection. If you are looking at this curve, performance curve, so on the x-axis we have the flow rate, and on the y-axis we have the head, dynamic head indicated. And this is a typical example of one of the pumps with 1450 RPM, which runs on 4-pole motor. I'll show you some selection which I have indicated here. Yeah. So if you look at one, let us take one example of flow rate 30 liters per second and a head, dynamic head of 50 meters. So here the pump which is selected is 180, the model is 180-400 with 409 mm impeller dial, and the power of the motor is 30 kilowatt. Now if you look at the curve, on the x-axis we have this flow which is 30 liter per second, it is indicated, and then when you go up and draw a line up to the head, the dynamic head which is indicated on the left hand side, which is on the y-axis with 50 meters. So it gives us the impellers which are here. If you see the impellers on the top of the curve, like 409, 395, 380, 365, 350, 335 and 320. These are the impeller, various impeller diameters. But our pump, which is selected on 30 liters per second at 50 meters, goes at just before the curve impeller dia, which is 409. So we select the pump which is on the upper side of this point. Okay, and we can also see the NPSH, which is net positive suction head required. The pump we select, the net positive suction head will be called as the net positive suction head required. So for this pump, the net positive suction head which is required, if you look at the curve, it's about 2 meters. The net positive suction head required by this pump, by this specific model, is 2 meters. So now what does it mean? It means the net positive suction head actual, which is A, which is at the site. You know, every day project site has got its own net positive suction head. So it should be more than this, which is required. It means the net positive suction head at the site should be at least 3 meters now in this case. Since the required is 2 meters for this particular pump, the actual pump head, the NPSH, should be about 3 meters or 4 meters. Then the pump which is selected is right. Because why we take care of the net positive suction head? Because the pumps will not face the issue of cavitation. Because if you know the net positive section head actual is less than the net positive section head required, then the pump won't have any problem because it will run, of course. I mean, 1 year and 2 years. Then there will be a problem of cavitation in the pump itself. And then due to cavitation, there will be a damage to the mechanical seal, the bearings, the shaft. It could be anything, impeller, So it damages the complete pump. So we need to take care of, when we are selecting the pump itself, it is not only to do just with the pump model, but it has also got to do with the net positive section head, which is more important. And when you look at the power required to run this pump for this duty condition, if you go down on the pump curve, on the motor curve, 30 liter per second, and on this impeller size of 3409, it is showing 24 kilowatt. If you see the corresponding kilowatt rating, which is mentioned on the y-axis, bottom of the curve, if you look at the motor curve, which is for the kilowatt rating, at the duty condition, the absorbed power required, the absorbed power is 24 kilowatt at 30 liter per second and 50 meter. But if you go to the end of the curve, the same curve, if you go to the end of the curve and draw a corresponding line to the motor rating, it's coming 30 kilowatt. So that's the reason why we have selected 30 kilowatt, which is required to run this pump. Even though the absorbed power is only 24 kilowatt for this particular selection. Hope it is clear for the pump selection. Okay, common mistakes what we do normally in making the selections, oversizing. As we have just seen in the last slide, even though we could have easily taken 37 kilowatt of motor because it is selected on 30, but no, since the absorbed power is only 24, we don't need to go for the higher rating of motor. Then the wrong selection of material itself, like as I told you, we can either use cast iron casing or stainless steel casing or anything, but it really depends on the type of water which is being used in the building. The type of water means the conductivity of the water itself. Then ignoring the life cycle cost, expensive operation and maintenance, of course. Okay, here's a typical calculation for making the flow rate and head from the chiller itself, because it's a chill water system. So if let's say we have a chiller of 250 ton, so with using this formula of Q flow rate is equal to tonnage into 3.517 divided by delta T, which is normally used as 5 degrees centigrade in chill water segment, into 4.186. This will give us the flow rate. So which has come about 41.9 liter per second. And when we are making the calculation for the head loss, this is just a typical example, guys. The actual flow rates and heads, we can calculate it by using, different methods as well. Now, the head loss calculation, which is considered as the losses within the pipes, these are called the friction losses, which is about 20 meters. And then the equipment like coil, chillers, valves, FCUs, AHUs and all is amounting to, let's say, 10 meters in all total. The sum of all is 10 meters. And we take a safety margin of 5 meters, then the head will be considered as 35 meters. So typically for any chiller, when we have the tonnage, it is easy to calculate roughly the flow rate of the chiller itself, flow rate required by the pump. Okay. And of course, when we are making the head calculations, which probably we might have another session, I will request our organizers of UAE MEP team to organize another webinar on the head calculation itself, where I'll probably give you a typical examples of how we normally do the calculations of head for the chill water segment itself. Yeah. And the power, of course, I mean, we have selected the pump based on the flow rate and the head. Now the power required. So if you look at, if you remember the curve, the performance curve, it was showing everything. On top of the curve, you are getting the pump with the flow rate and head. You are selecting the pump model. And if you go to the bottom of the curve, you can select based on the same duty conditions. You can select the capacity of the motor required to run this pump efficiently. The same thing is also being calculated in this way. I mean, the power is also being calculated, the power required for the motor itself. And energy optimization tips for chill water pumps, as we discussed in our previous slides as well. So today, the technology has developed so much that we don't even need to go to the pump to actually operate it, and we don't need the technicians and the maintenance guys to be always with the, stand as a standby near the pump room or near the building. No need. We can do everything on even the mobile now. Even if you are not here in UAE, if in India, you can do, easily the maintenance of the pumps. I mean, you can find, of course, you can identify the faults, and of course, you can tell to your team, go there and just change this bearing, change the mechanical seal, or something like that in the pumps. So, various energy optimization tips for the chill water pumps obviously will be to start with. It will be like using the VFDs and motors like IE5 motors as of today, what we have, and selecting the pumps. Obviously, when we are selecting the pumps, we should select the pump which is very near to the BEP. BEP is like the best efficiency point. For every pump, there will be one best efficiency point, like say 80% or 85%, 82% will be the best efficiency. So whatever pump we select based on our duty conditions, the selection should be very near to the best efficiency point. So that way we can also optimize, the pump efficiency. Minimum oversizing, as we discussed in our last slide as well, the oversizing should be very minimal. And of course, the proper pipe sizing to reduce the head losses. So all these points will actually help in optimizing the unit, which is for the chill water pumps within the segment. And of course, the regular maintenance which is required for longer life and lower cost. But now, when it comes to regular maintenance, it doesn't mean again that we need to be near the pump or the pump room and then we do the maintenance side. No, we can do this. I mean, even remotely. As on today, we have IoT-enabled sensors and everything, which are being connected to the pumps, and we can use it from our mobile, from our offices or the laptops, and then we can just guide our technical team to go there and replace these things and do the periodic maintenance of, with by replacing the seals, or it could be bearings or shaft, etc. Adopt IE5 motors, ultra premium efficiency. Now, IE5 motors are the top of the game now, because these are giving like about more than 95% of efficiencies for the motors. Yeah. So higher the efficiency of the motor, lower the cost of the pump maintenance. And obviously, as I was discussing about the IoT-enabled monitoring and control, all these pumps are now, whichever we are using, at least the pumps we are using, are all IoT-enabled and which are capable, I mean, which are compatible by using with IoT-enabled sensors and monitoring and controls. So by combining all these above factors like VFDs, the proper selection of pump, IoT monitoring, chill water systems can achieve about 20 to 40% energy savings compared to conventional pump installations. So it means, guys, if you are spending 100 dirham for this pump today, so you don't need to spend anymore. You'll be spending only 60 dirhams for the same pump by utilizing all these things. So choose pump type based on application. Focus on efficiency with the best efficiency point and the VFDs. The right selection saves, the operating cost and increases its reliability. And always check calculations, because whenever we do the calculations for the power, for the curve itself, like sometimes we are human beings, we might be wrong sometimes, but we need to cross check if we have done the proper selection based on our duty conditions or not. That will also really help. Yeah, thank you, guys. I'm open for questions and question and answer session.
Hello.
Yeah.
For the selection of chemical dosing, we have like two types, manual and pump system.
One is manual, the other one is automatic. Yeah.
So for the pump selection, what type of like how much pressure and flow we need to be consider?
No, see, actually, we have, it is very typical, I mean, this question is very good actually. We don't need a pump of the same pressure and things which are required for the chill water itself. No.
Yes, because it is on the suction side.
Exactly.
Mhm.
I mean, the system pressure is actually not meant for the dosing pump itself because it is just in line just to pump the chemical from the top. It is not within the system.
Like if suppose the inline pressure is more than the whatever the pressure which is feeding, it will go the back
It will
to.
not affect.
Can I answer to this question if you allow, Mr.
Yeah,
Rashid?
please.
Well, see, I understand your query. Your query is about what would be the set point for the chemical dosing pump for the system. Correct me if I'm wrong.
Yes, right.
Okay. So to answer this, during the testing and commissioning, after the system is stabilized, you can keep your chemical dosing pump cutout pressure and cut-in pressure one bar higher than the system pressure. That means if your pressure is 1 bar higher than the system pressure, you will be able to pump in the chemical.
I'm not getting. System pressure means it will be on the like
Suction side,
before.
correct. Let's say your suction side pressure is like 3 bar. Okay.
Mhm.
You can when the suction pressure is 3 bar and the
Mhm.
chemical dosing pump system you can keep the 4 bar because when the chemical quality is monitored, the 4 bar pump can pressure in the 3 bar system.
Yes. Mhm.
That's the answer. Thank you.
Same is for the expansion tank also, right?
Similarly, yes, definitely. This is the technical queries usually engineer faces during the testing and commissioning. Usually designers, they don't give the set points of the pressurization, all these stuffs and all. This will be
Yes.
derived during the testing and commissioning. Once the system is stabilized, you need to have the higher pressure side in order to pump into the system. Okay.
Yes.
Thank you.
And one more question I have. When we need to take care of the NPSH?
Always.
Always means if suppose the system, see the pump and the tank is in line, then also we need to take care.
No. It is not the question of pump in line or not. See,
Uh-huh.
NPSS basically we need to understand. It's a very good subject, I think, where we normally neglect. NPSH is basically, as we discussed, it is net positive suction head, which is available at the site itself. In the project site,
Mhm.
whether you are mounting and installing the pump positive side, or is it going underground or under in the basement, it really depends on that. So you need to find out what is the actual NPSH available at different project sites. Now, based on that, you need to give the information to the supplier, whoever is supplying the pump. Baba, I need the pump with such and such NPSH because my available NPSH is just this much.
So like how much NPSH we need, how we can calculate?
No, NPSH depends because it depends. See, for the pumps, if I talk about the pump itself, different kind of pumps have different NPSH. Higher the pump size, higher the NPSH. Lesser the pump size, lesser the NPSH, which is required. This from the pump side is required, but the actual NPSH is at your site itself, where you are trying to install the pump.
So what parameters we need to check for calculating or considering NPSH?
There are so many factors, like suction lift is there, absolute pressure is there, vapor pressure is there. All these you need to calculate, sum it up, and then you will get the final NPSH, which is there at the site.
Hello, sir. Hello.
Yeah.
Hello.
Yeah.
How to consider the head loss for a chilled water pump? Can you just explain me like it says no circuit, right? Suppose for
That as I just okay, thank you for your question. But as I told in my previous slides now, that this is a good and big subject actually. for the head loss calculations, which is friction loss calculation also it's called. So we will have a different session. I will request the organizers to have one more session
Yes,
later.
we'll be having like
for the
each
head loss
point will be
calculations.
there, no? That each point we have to consider all the eliminations and then only we'll get the pipe loss. No, that is the only thing just I have to ask.
Yeah, that's right. You're right.
So there is one question from Azhar Aziz. Can you go ahead, Azhar? Mr. Azhar, do you have a question?
I have a question.
Yes, Bijit,
Hello?
tell me.
Yeah.
Yeah, go ahead.
Can you select two-pole motor instead of four-pole in the secondary side?
Yes, obviously you can select it. See, normally what happens is we are running the secondary sets mostly on the VFDs. Okay,
Yes.
so when we are running the pump on the VFD, it really doesn't matter whether the pump is the motor is running with 1450 or 2900 RPM, two pole or four pole, because we can control it through the VFD. Yeah, but when you are using the motors of 2900 RPM, which is two pole, without the VFD, then the life cycle of the motor will be very less because it is running, like double the speed, four pole motor.
Go ahead, Azhar. Azhar, your question, please. Hello, Azhar. There is one more gentleman, Mr. Yusuf, also raised his hand for a question. If Yusuf is available.
Yes.
Yes, sir. Actually, I have one doubt. Like you have proposed 3 chill waters, right? Pumps, out of which is
circuits.
like hello.
Yeah, 3 circuits are proposed. Yeah.
Yeah, 3 you have proposed. Out of which is the for while coming in the maintenance, which is like tough.
Obviously, the pump which is coming in the secondary circuit, because it is varying by the loads, different loads and everything, and which is pressure dependent. So I would consider it as secondary circuit.
Okay, sir. Noted, sir.
Yeah. Thank you.
Yeah. Any other questions are there? Azhar, Umar Farooq, please go ahead with the question. Any questions from Umar? Okay, Masih now I think there's I have one question. As a presenter, we can ask this question also for the benefit of our community. We have experienced a case in our projects that the primary side pumps are experiencing complete design water flow, but from the secondary side, the water flow was not sufficient.
Okay.
So what? It was opposite. The primary side was not experiencing the complete water, but secondary it was completing the full requirement.
Yeah.
So due to this, what was happening? The primary side, the chiller was working continuously. And then, the chiller electrical bills were increasing drastically. So what we made to do is we made a rebalancing of the complete system of the project. Then we were able to achieve the results. So what my concern here is, once the chill water is balanced in a project, I think, in my opinion, it needs to be rebalanced after a couple of years.
Exactly.
So what are your thoughts? I mean, just if you can.
Thank you very much, Mr. Sayyed, for this question. And it's a good question, actually. Obviously, as you rightly said, normally when we do the balancing of the water, at the initial stages of the project, and then khalas, we forget it about till the pumps are run dry. So this is not basically acceptable, because it has to be rebalanced, even if not every 2 years, at least in 3 years, it has to be rebalanced. And then the system will work in a way it has to. Because as you said, the primary circuit, it was giving you the complete flow. It means it was pumping through the chiller, it was good. But when
Yes.
it's going from the chiller, because it has got varied loads now, and there are a lot of pressure losses, variations, it was not coming that kind of flow which was required. Am I right?
Yeah.
Yeah, so this rebalancing has to be done, if at least not in a couple of years, at least 3 years, every 3 years, it has to be redone. That's true.
And another question is, do we need to keep the chill water flow meter on both the sides, primary as well as the secondary?
Yeah, it is better to keep it that way, because it can then easily, you will be able to really see. Now, in this case of yours, as an example, say,
Yeah.
for example, if the flow meter is not there in the primary side, so you will never come to know that the problem was actually from the secondary.
Yeah.
Yeah, so it is better to keep always on both the sides.
And the how much GPM it is flowing on both the sides.
Yeah.
So that is also a requirement.
Yes, of course. And this type of pump, which I was talking about in my session now, it has got, there is no need for you to have a different flow meter as well. It will show you the flow at the pump itself, on the pump itself with the display.
Okay.
Yeah.
It's good thing. There's one question I think Arifullah Beg has put here. Decoupler line, flow meter in decoupler line. What exactly you want to say, Arifullah? If you can go ahead with your question. Yeah, Azhar Aziz, please go ahead. Azhar, you can unmute your mic and go ahead with the question.
Mr. Azhar has asked his question in chat box.
Yeah.
In case of vertical inline pumps, 2-pole or 4-pole, what's impact on CHW systems?
What's impact on?
Chill water system.
Chill water systems.
What is the impact of? No, it is not an direct impact on the chill water system, but it's definitely an impact on the life of the pump itself. Because see, when we are saying 1450 4-pole, the motor runs on 1450 RPM, right? And the same motor, if we are using it for a 2-pole motor, then it's running on 2900 RPM. So obviously, the higher the speed, lower the life expectancy of the motor itself.
I think there are no more questions are here, and we will wait for a couple of minutes, and any other data we can share with. And nowadays, Masisa, this on the piping side, there are a lot of projects coming up with PPR piping as a chill water.
That's true.
You want to put any thoughts on it, one?
Yeah, basically, even in our chill water skids, nowadays we are shifting it from, obviously from the GI, we have already come back to this thing, what you call stainless steel. And now we are shifting it to PPR as well, even in the pump skids. Okay. So similarly, even in the piping side of the chill water segment, PPR is the best, I can say. But there will be there won't be a much of price impact, when it comes to changing the material itself, because with the PPR we are adding a lot of connectors which are required.
Yeah. There is one question from Abdurrahim. Is inbuilt VFD is recommended? What is the challenges? Is it available in major brands in UAE market?
Yes, of course it's available. There are no challenges because in fact you are saving a lot of time and energy, space and everything, when we are going with inbuilt VFD kind of pump compared to the traditional huge control panel with a lot of VFDs inside and connecting it to the pumps, it is always better. Yes.
Okay, I think this was a very informative session, and as you told Mr. Masih, we will have another session
Yes.
for the ESP calculations, especially,
Yeah.
and definitely we will put it in our next agenda.
Sure.
And we'll have it you on board for our session again.
Sure.
So Azhar Aziz, before we close this one, as a last question I'm taking, Azhar Aziz has put one more question here. In case of primary pump only VFD, what's the guideline for bypass line and valve?
No, I didn't get it. For the primary pump?
If there is a primary pump, only primary system, he means to say there is
There
no
is no
secondary
secondary.
system.
There is no secondary. Okay, so
Yeah.
it is both the primary and secondary is same. Okay.
Same, yeah.
Yeah.
So his question is, what is the guideline for bypass line and valve? So how will we need to have a bypass line in both the case?
Yeah.
Yeah. I think Azhar, you are able to accept or hello, Azhar, are you able to hear us? As Mr. Masih said, the bypass line is necessary in both the systems, primary as well as the secondary.
Yes.
Yeah. So guys, we will close down this session, and whatever, if you have any other questions, you can post it on the group or you can send it as an email to our website, and we will get back to you with the answers. And whoever has attended this session, you will be getting a certificate as well, and duly it will be attested by signed by Mr. Masih as well for the certificates. And thank you very much for joining. And you people can also follow us on our WhatsApp channel and other social media pages. And inshallah, we will see you in the next coming up webinar.
Thank you, Mr. Masih. Thank you for your time. Thank you, everybody, for taking such an initiative.
Thank you very much, sir.
Thank you.
Thank you. Thank you very much.
Yes.
Right. Thank you, Masih Saab. Assalamu alaikum.
Wal-Islam.